Hello and welcome back to this video series on data and data modeling. In the previous video, we talked about the difference between a conceptual versus a logical versus a physical data model. There is also something called an internal data structure or data model. In this video, I want to use a tool called draw.io and begin to craft what we call an ERD diagram, which is going to essentially craft the models that we've been building that led from a conceptual to a logical, and then we're going to eventually take that into being a physical data model. So logical data model, we talked about this in a previous video, but with the logical data model, how is it different from a conceptual model is that we began to define the various attributes, the types of information that you would need for each entity. And we get that from the data requirements, the business description, the business rules that we've crafted. So here's an example of a subschema of our database. When I say subschema, I'm referring to a portion of our database, not the entire database. But here we have three entities. And then to the right here, you'll see some of the things that we'll depict in our ERD diagram. We'll depict the name. We'll also indicate the strength, the relationship strength, whether it's weak or strong, the primary key and foreign key, the cardinality, as well as if it's null or attribute could be null or not null. And then also within a logical model, you begin to specify the various keys as what I just previously mentioned. So you have primary key, foreign key, constraints on these various entities. And so if you look at the property here, property has a primary key, and we notate that in this first column of this entity, but also has a foreign key. That's then we use FK for foreign key. And then we have our associative entity that has both a primary key and a foreign key. And if you have two primary keys and two foreign keys, you can just notate the foreign key by 1 and 2. And then our amenity have a primary key that's represented by amen_num. Now, when you're looking at this this subschema of this ERD model, you can also depict who should get the foreign key and who should not based on the relationship. So I think we have a good idea of how the name is derived. So we give it a noun, and it's a singular, not properties, but property. We'll talk a little bit more about the entity strength and the relationship strength, but the primary key and the foreign key, we can figure out who gets the foreign key based on a relationship. And so how does property get the foreign key of this prop class num? Or better yet, how does prop amenless entity get the foreign key of prop amen prop ID, which is essentially getting the foreign key of property? We name it a little bit something, we name it differently here in the prop amen list to distinguish that it's a foreign key, but also a primary key of prop amen list. And then what I've done here is I use a tool called draw.io, and I've recreated this diagram. And you're going to, I would say, get some practice with this. You're going to get some practice with this in an activity later on in this slide deck in terms of how to create this within a tool called draw.io. And there's many different tools you can create these ERD diagrams in, but draw.io is a free web-based tool. But I'm going to click over to the next tab. And so here's my ERD diagram that I drew up inside of draw.io. And like I said, we'll get further practice with this in terms of how to create these entities and how to associate the various lines between the entities and so forth. But down below here, what I'm going to point your attention to is this statement here. In a one-to-many relationship, the one side passes its primary key to the many side. So if we take a look at amenity and prop amenless, we say that the way this is read is that an amenity can be associated with one or more prop amenless, which essentially is saying that amenity can be associated with one or more properties. And then, but in this case here, in a one-to-many relationship, the one side passes its primary key. So my primary key is going to be passed to the many side. And so you'll see that prop amen_num is the foreign key for amenity. We'll talk about the relationship strength in just a minute here, but let me just jump back to our slide deck. Let me first talk about entity strength. How do you indicate entity strength within this diagram? The entity strength is dependent upon if the entity has a sole primary key. And so in this case here, property and amenity are both what we would call strong entities. And that's different from the relationship strength, but property and amenity would be considered strong entities because their existence doesn't depend upon any other entity. An example of a weak entity is that it may consist of a composite key. So proper min list is what we would consider a composite key. It's more than one primary key. And so if we were to delete the property from property amend list and delete the amenity, then it's essentially dependent upon one of these particular entities. So this property amend list will be considered a weak entity. And the way to indicate that is that it doesn't have a sole primary key. That's one cheat code. How do you recognize a strong entity versus a weak entity? Look at how the primary key is specified. If it's a composite key, such as what we have here, then it's a weak entity. If it has its own primary key, then it would be considered a strong entity. And again, it's a situation where the entity doesn't. What makes it a strong entity is that it doesn't. Its existence doesn't depend upon any other entity. In this case here, a proper min list depends upon property as well as amenity. Another situation, a practical situation that you may run into a weak entity is where you may have, let's say you're an employee and you have a dependent in the database. If you're an employee, you'll be considered a strong entity, but the dependents table, which will hold your children or your spouse, will be considered a weak entity. So if you were to delete the employee, which is the strong entity, the weak entity of your that's associated with that strong entity would all be deleted. And so all of your children and your spouse should also be deleted because they'll be held within another table called dependent. And that dependent table should have a composite key of your key or the employee key as well as a dependent key. And so that's another example of weak and strong entity. All right, so the next thing to determine here is the relationship strength. The relationship strength is determined by its signals, or it's depicted by the line. It's depicted by the line between the various entities. Let me bring up my pencil here. And so here you'll see that we have a solid line, and then we have a dotted line here, and that's indicating the strength of the relationship between two entities. Now, this also plays a little bit into understanding if it's a weak entity or a strong entity. But how this works is that, let's say, for instance, if I were to delete an amenity, if it's a strong relationship between these two entities, let's say prop amend list and amenity, if I were to delete the amenity, I want to delete or truncate and delete all of the corresponding property amend list from my weak entity. Now, I don't have the entity shown here, but there's another entity that's called classifications. And you'll see that the relationship between property and classifications is considered a weak relationship. So even though property is a strong entity, the relationship between classifications and property is considered weak. Why? It's because if I were to delete a property, I don't want to truncate or delete all of the corresponding classifications. I'll say that again. If I delete a property, I don't want to truncate or delete any of the classifications. So classifications is also considered a strong entity. And that's why I say that there's some correlation between the relationship strength as well as the the entity strength. So two strong entities would typically indicate a weak relationship. And then in this case here, we have a strong entity, and we have a weak entity. In this case here, the relationship strength is strong. And again, just to repeat myself here, is that if you delete an amenity based on the relationship, we're going to truncate and delete all of the corresponding property amend list that are on this, that are associated with this weak entity of prop amend list. Okay, let me talk about two more things before I end this video. It's getting a little over the time limit that I would desire. And I want to talk about the cardinality. I always have a hard time saying that word. Cardinality, which is this word here, right? And we've already kind of discussed what that means here, but what we're looking at is these things here. So here, this is what we would consider a 1 to 1. And this here is we consider a 1 to many. And then here will be considered a 0 to many. And the same thing here is a 0 to many. And then this is a 1 to 1, 1 to 1. You may also see something such as where you may see a 0 to 1, and that's not the best drawing, but instead of just having two lines, it may be a 0 and a 1, like, or not a 0, but a open O and then 1, which means 0 to 1. So how is this read? We'll say that an amenity can be associated with 0 or more, or 0 or many. And then here, if we were to say property, from property amend list to property, we could say a property amend list can be associated with 1 and only 1 property. If it was something that looks like this here, if we were to change this, let's see, and say that, or change that to that, I know this is kind of not clear. We would say a property amend list could be associated with 0 or 1 property. And so this is very important when we're specifying how many instances can one thing have. And so in this case here, we can't see the classifications table, but what we're saying is that a classification can be associated with 0 or more. So a classification doesn't have to be associated with a property, but it can pertain to, so a property can have, sorry, a classification can be associated with 0 or more properties. So a property doesn't have to necessarily have a particular classification associated with it. But if it said 1 or more, then it must have a classification. And so we're saying that property, in this case, doesn't have to have a particular classification. Last but not least is this idea of null versus not null. And that's indicated by the boldness of the attribute. And so in this case, property long description can be considered null because it's not bolded. And then, but prop bed range, prop bath range are all not null attributes. And so, and that, again, that's indicated by the bolding of the attribute. Now, I'm going to pause this video, but in our next video, I want to take a step back and begin to actually formulate writing down business rules and then taking an example of a previous activity and draw out the ERD diagram and specify some of the things that we see here that we just identified that we can depict within our ERD diagram. So stay tuned for that video.